Hello, this is the code review for SoundStage. We made a VST plugin using the Juice framework in C++. So there's three main classes within this plugin. Plugin processor, which handles all of the audio processing. Convolution, which is a child, which plugin processor has. This is where all the convolution math gets takes place, the whole functionality there. And plugin editor, which is the UI, the look and feel, the user interface of the plugin. So let's start off with the UI first. This is our elevation control, which is this slider right here. This next one's the azimuth slider settings, which is this knob right here. And anytime either of these values are updated, the corresponding variables in audio processor also get updated, as you can see right here. Now let's move on to plugin processor. When this object is first created, the azimuth and elevation values are initialized to 0, and a new convolution object is created. We'll get into that a little bit later. So this receives an audio stream, one audio block at a time. And every time a new audio block is received, this process block gets called. So first, we make the signal mono by summing the left and right signals together. Make a copy of that buffer. This is for convolution purposes. Send the azimuth and elevation values to the convoluter. Apply the output from the convoluter, and then read the input, which is the current buffer that we're at, into the convoluter. So now I'll go into how the convolution algorithm works, and I have a diagram here that well represents it. So this at the top is the audio buffer stream. Each block is read in by the input reader, and then once this input reader fills up with a predetermined amount of buffers, it sends this to be convoluted. The convoluted signal is created, but since the convoluted signal is larger than the input signal, we have to store the overflow for the next cycle. So after that's stored, the initial convoluted signal minus the overflow part is sent to the convoluted output and applied back to the buffer one block at a time. So in the code, the convolution first sends the output. The convoluter applies output first. This is for logic purposes, that it applies output before it reads the input. So within the applying the output part, for each channel in the current buffer that we're at, which would be this in this case, we get a pointer to this audio block right here, and then it gets appended to the audio stream. From the input, we read in one at a time until it gets full, until this buffer is filled up. And then when the buffer is filled up, we call the convolute method, which this is all the convolution algorithm right here. And then this adds the overflow to the convolution storage. And then the overflow storage, this right here takes this convoluted overflow storage, the current one, and applies it back to the next convoluted signal. So initially, this is empty. Once one convolution happens, this is full. And then when another convolution happens, it applies it to that one, if that makes sense. After that, we push the convoluted signal to the output buffer and then generate the overflow storage from the convoluted signal. Yeah, that's about it. Thank you.